Hello, my name is Chris Moberg, and I'm going to be giving a brief overview of how to configure gauges in Quantum. The reason for configuring gauges is when Quantum ships, it has a set of default gauges. These are neither configured for your particular model of dyno or the type of cars that you see. So to maximize your operator experience, you really want a set of gauges that show you the data as it's unfolding during the pull. If you have all-wheel drive, you may want to see different things than if you have two-wheel drive, for example. So with that said, let's launch into looking at gauges. As you may know, gauges come up automatically when you start a run, but this isn't the place where you ought to edit them. We want to access the gauge screen from the home ribbon within Quantum. So we click Gauges, and up comes the default gauge panel. This is my gauge panel for an all-wheel drive 15,000. It gives me insight into what's happening on each roll of the dyno, telling me what's happening with my eddy brakes, air fuel, so on and so forth. It's a little complicated, so we're not going to use that as the training vehicle. We'll do multi-gauge and chart. This is a gauge panel that I think ships with Quantum. And so we're going to first make a copy of this because we don't want to be changing the gauge that was distributed with the software. We want to have a working copy so that we can always go back to the factory or defaults, if you will. So now what I'm going to do is I'm going to load my demo gauge panel, and you see it's an exact copy of the one that we cloned. Now we have some basic editing capability here. We can go into layout mode, which is informing the gauge panel that we're going to be changing how the panel is arranged. Want to click modify. You'll notice that the background now goes from black to having dots. We can choose a gauge on the panel by clicking somewhere in the gauge, and then we can delete it. In this case, I'm going to get rid of some of these because it's kind of busy, and this is an important skill that you often want to start with a gauge panel that exists and trim it and modify it, as opposed to creating one from scratch. We have an ability to copy existing gauges, add new ones to a panel, and so some combination of those two things is really the fastest way to configure new gauges. So let me just click on a few more of these. I'm just hitting the I'm selecting and hitting the delete key. So now I have basically removed a number of gauges, given me some more room on the canvas. I'm going to click on these two air fuels, and I'm going to now grab them and I'm going to put them over here. So they don't look so pretty, but the point here, I'm just trying to show you the mechanics of moving things around. So what I want to do next is show you the properties. And a key point about properties is they're the same for every type of gauge. So, you know, this is a great feature because it allows you, once you get confident in modifying the properties on, say, a round gauge, it works on any of the other types of gauges. So let's just step through the data fields in the properties. You have an enable or disable capability on the gauge. You know, I don't think I've ever used disable. If it's on the gauge panel, you probably want it enabled. And a title and subtitle, this is the area where those fields manifest. I say that you generally want to go to your data source first. This is the channel in the data, and we have a drop down and we can find many different data channels. And a point worth noting is these are the very same data channels that you have on your graph. So think of this as the real-time display of those channels, and then when the run finishes and you go back to your graph, on your left and right borders, you have the same channels to select. So we often have greater density on the gauge panel, however, so you can watch more channels than you can see on one or more graphs when the run is complete. Another point is when you choose a data source, it has knowledge about what that data label is, and so it will fill in the titles automatically for you. So procedurally, you probably want to choose the data source first, and then it'll auto-populate the title. You have a choice of units. One of the features in Quantum is a very flexible ability to choose display units that are independent of the capture units or the default units of the data as it comes in from the dyno. This is true both on the graph and on the gauge. So, for our friends in Europe and England, often there's a desire to see some of the fields in metric. I think England actually uses kind of a mixture of metric and English, and the balance of Europe uses pure metric. But the point is here, you can mix and match some metric, some English, however you want. This software is also sold into the industrial market, and so there are even some units that don't seem to make sense within a automotive field, but for an industrial application, you can see they have merit. Subdata is the second channel within a gauge. If we look here at this speedo/tach, it has two data channels that it's showing you, the speed and the RPM of the vehicle. And so the subdata defines the second channel. And so it has a source, a unit, and value that will come from the dyno as the gauge is active. Scale. This is a critical thing. This is the min and the max for the gauge, and often when the gauges are created, the default gauges, they're set with very high maxes. So let's say you're a diesel shop, and here you have engine speed goes up to 8,000. Well, very rarely does a diesel go that high, and so one of the things you want with your gauge is that when the needle swings, you have full range of the needle within the min and max that are going to be achieved on the dyno. So one of the things we can do here, we say, RPM on this gauge is really going from 0 to 8,000, but this diesel really only going to 5,000. So I can click it, and you notice that now it goes to 5,000, but I used to have yellow and red here, and I've lost that. So that brings me down to, let me not skip over scale multiplier. Generally, we don't want to be multiplying the data value, but it's there if you, like on air fuel, if you needed to rescale it for some reason, you could. Generally speaking, leave it at 1. So if I want a warning min on my diesel of 4,000 and a critical at 4,500, now I get my yellow and my red at the appropriate points based on the properties I've set for the gauge. So now the next two fields are probably the most misunderstood ones in all of the gauge properties. I get the most questions on, like, how do you set this step and max step? So let me demystify this. The step is the minor tick. How many of those things, in this case RPM, is represented in the minor tick? The max step is how many minor ticks are contained between the major ticks, and the major ticks have numeric labels. So if I change this to from 5, so 5 times 200 is 1,000. So if we look at the gauge, it goes 1,000, 2,000, 3,000, and we have ticks of 2,200, 2,400, 2,600, 2,800, 3,000. But if I go here and I make this 100, and I then say this is, well, let's look at it when I change it to 100. Well, I had 5, and so 5 times 100 is 500. So now my major ticks are 500, 1,000, 1,500, and so on. So you can see that the multiplying the max step times the step gives you the major ticks on the gauge. So we can go back, and there's different ways of achieving the same mixture of ticks and with different numbers. So if I put 10 in here, well, now I'm back to my 1,000, 2,000, 3,000, but instead of having steps of 200 for my minors, I have steps of 100. Okay, so great flexibility on how the legends work on the gauges. And this, I'm showing this on a round gauge, but it's the same on a bar graph gauge or so on. Submin, submax, multiplier, critical levels. These are all the same. So for the subscale, so I'm not going to spend any time really on them. They work the same on the other channel. Appearance, it's a theme. So if I want it to be blue, notice the background changes to be blue. If I want it to be black, seems like the popular ones that people use are black or white. We have a style of the gauge that's really it's really a sub-style. We have a round gauge, and now it's a combo. It could be a combo analog, which is just the needles. This is a combo with both a needle and a digital value inside. Let me say that when working in digital values, you have to be careful for your desire for accuracy and resolution, with the recognition that when this pull is happening, the values are changing pretty fast, like on speed. And so you may not want to have tenths in speed, because it may make it cloudy or fuzzy when you're trying to look at that, because the tenths are always changing. It may be more satisfying to just have whole units. RPM is another case. You might want not ones, but maybe tens or something. But great personality changes to the gauges are possible. So you make it work the way you want it to work. Are parts of it visible? Generally, you don't want to be turning that on and off. Here you have the number of digits for the cells, the number of decimals for the cell, the colors that correspond to the warning in critical. Like if you don't like yellow and red, you can change it to something else. Generally, I don't see people doing that typically. And lastly, this is the position of the gauge. I think this is generally more reference for you. Most of the time when I create gauges, I may look at this to see if I've got the gauges like aligned on gauges. So let's look at a couple of other skill items. As I said, you often are copying, cloning. So let's say I'll get, well, why don't I just delete these to make some more space? So delete that one, delete this one. Now I'm going to click this one, and I'm going to go copy, and I'm going to say paste, and then I'm going to drag it, and now I have a copy of it. So, skills that you have from other Windows programs, cut, paste, copy, paste, they sort of work in here. Why would you want to copy this gauge? Well, it's a shortcut. If you want to make another gauge that looks kind of like that, has two data channels, has mins and maxes, maybe sort of the same. Like when I made my all-wheel drive panel, my little gauges for horsepower and torque, they're really the same. It's just whether the data source is on one roll or the other. So this is a perfect example of when you'd want to copy. But I'm just kind of artificially showing you a copy here. If we want to create a numeric gauge, I can grab it from the toolbar and put it on the canvas. A horizontal gauge, a vertical scroll. But let me just show you in properties here. They are somewhat simplified, but it's a subset of what we saw in the round gauge. So it's probably not that the properties are exactly the same between different display types, or gauge faces. The round ones are the most complicated. So if you get the round ones, then everything else is just a subset of the round ones, really. That's an overview of the properties. Now let me show you another important thing to do with your gauges. So what I want you to see here is I have a gauge panel called low power all-wheel drive. I have one called mid-power all-wheel drive and one called high-power all-wheel drive. So let me open this one. So once again, this is my gauge panel. But look at the power. This is power on the rear roll, power on the front roll, torque on the rear, torque on the front. But the salient point here is it goes up to 350 horsepower on each. My total horsepower is 600. So why do I have this thing? These values set this way? It's when I have, sort of the bread and butter of an all-wheel drive dyno up in Maine, where I'm located, Subarus and Mitsubishi Evos and Eclipses and the like. And, they're fairly low-powered import all-wheel drive cars. So, once again, to have maximum needle sweep, I need gauges that are configured for that mix of vehicles. On the other hand, if I am doing a bunch of diesel trucks on a dyno day, or I just have a diesel truck coming in for tuning, that's not going to be a good gauge panel for that purpose because the gauges don't go high enough. So I might go for mid-power. Now, the panel looks the same at first blush, but now each roll goes to 600 and the total goes to 1200. So when I'm doing that diesel truck, I'm probably only doing it in two-wheel drive, so I am wasting some space. I don't have a cross product of power and number of drive axles, because you have to decide, like, how many screens do you want? And my decision was I'll just break it on power, and I will recognize that the the secondary roll, represented by this gauge and this gauge, won't be moving when I'm in two-wheel drive. But if I'm in front-wheel drive, they probably move and the other ones don't move. So it's one panel, and you just have to be cognizant that depending on which roll in an all-wheel drive situation is turning, that some of your gauges may not move and other ones would. So, but now I can go up to 1,200 foot-pounds and 1,200 horsepower. So for most moderate diesels, this is fine. And then I have a high-powered one which goes up to, like the max that the dyno can do. Now, in the center here, if you have an eddy brake, I recommend something like this. The gauge down here, PAU command, that is the instruction from Quantum to the eddy brake in terms of a percentage of on time. So the higher the percentage of on time, the greater the braking force. When you do static, PAU command pops up to the percentage that you've set and stays there for the whole pull. If you do VRS or you're doing interpolated, you will see PAU command moves during the pull, showing you how the requested force is changing throughout the pull. So if you set interpolated going from a low value to a high value, you would expect PAU command I percent to go up during the pull. If you do VRS, it would also go up, but the shape of it going up would be quite different than a linear interpolated. So it can provide you with insight into what's going on. Now, these vertical bars, are the output of the load cells. So I have two eddy brakes, so I have two load cells. The purpose of having this here is to watch the recorded force, and secondarily, I can watch this to see if I have an EMI or a static issue that it's interfering with a load cell. If I start to see these bar graphs, go, haphazard, they're just bouncing up and down and whatnot, that is an indication that I have an EMI problem, or a static buildup. I forgot to put the ground strap on, or it did something of that sort. So they're very useful. It's also your confirmation that if you're putting 30%, you would sort of expect to see 30%-ish of the rated capacity of your eddy brake. It's not exactly going to be 30%, but that's a topic for another day. That's gauges in a nutshell, but I'm going to show you one other nice feature with gauges. I'll leave that gauge screen up. I will go to the home. I will go back to data view. Notice I have a pull here. Got runs 2 and 3. I'm going to select run 2 here. I'm going to go back to the gauges, and I am going to hit the play button on the gauge, and you can see that pull displayed on the gauges. And in particular, you can see that pull was done at 45%, or it ended at 45% load. I wasn't quite watching in the beginning, and You know, this is helpful if you are, looking to see more channels at once than the graph shows. If you thought you saw some anomaly when the pull was happening, you can go back and replay it on the gauge screen. So, gauges are a very powerful vehicle in quantum, and made even more powerful by your customizing of the gauge to suit the type of cars you do and the way you do your pulls. So thank you, and that concludes our training for the day.